I'm a little frustrated with the textbook and example 2 because of the angles they use. Because there's an easier way to do some of these questions. And so sometimes the way a question's written, I hope you could see, if you wanted to figure this out, you know what cos of pi over 4 is. And you know sine of pi over 4. You know they're both root 2 over 2. Does it make sense if you had root 2 over 2 squared, and you subtracted root 2 over 2 squared, that you would get 0? Does that make sense? So I could have given you this question, well, I wouldn't, not a week ago, because you'd be in spring break, but 2 or 3 weeks ago even, and you would get this right. But they want us to practice these new identities. So these angle choices are actually a little bit better. Okay? But some things in this question are important to look at. First of all, when you see sine squared and cos squared, the most typical formula that's going to trigger in your mind is the first one that you learned, right? Sine squared plus cos squared is equal to 1. You can't use that formula here because there's a minus sign, not a plus sign. However, we just got a new formula today. One of the cos 2 theta formulas has cos squared alpha minus sine squared alpha. So what that allows us to do in a question like this is we can say, if pi over 4 is the alpha, this would equal cos of 2 times pi over 4. And that would simplify, because 2 is 2 over 1, to cos of pi over 2. And pi over 2 is on our unit circle. What's the x coordinate right at the top here? It's equal to 0. Of course, we found out it was equal to 0 just using our pi plate normally, but it shows that if you use the formula, you get the same answer. Same problem with part B. Pi over 6 is on your pi plate. You could change tan of pi over 6 to root 3 over 3 in both of those places, and you could simplify and evaluate. It would be a little bit tricky because you have fractions inside fractions, so you really have to use your fraction rules, which would be fine, but you could simplify. What they want us to do in this one is notice that if you have a whole bunch of tans in a fraction, that we have some formulas, and our formula that we learned today for tan 2 alpha looks like this. But unfortunately, can you see that what they've given us doesn't quite match? It has the 2 tan pi over 6 in the top, so the top seems to match. But the bottom should be 1 minus tan squared, and we have tan squared minus 1. But there are some important math things that we get to remember when doing this question, so it's still good to practice. Okay? First of all, was this idea. If you have something so close to matching, but they're mixed up, you can always factor out a negative. If I factor a negative out of the bottom, the negative 1 would become positive, and the tan squared would become negative. So I hope you can see that we are now closer to having this match up perfectly with what the formula says. But it doesn't match up perfectly yet because there's still a negative. Now thinking about negatives in fractions, okay, and this is easy to see if I just use regular numbers. Do you know that 1 over negative 3 is the same as negative 1 over 3, which is the same as negative 1/3? There's 3 different ways you can have that negative when you have a fraction. There's one negative, it doesn't matter where it is, it could be on the bottom of the fraction, it could be on the top of the fraction, could be in front of the fraction. And in this case, the negative's on the bottom, but I'm going to put that negative like out in front. I wouldn't need the brackets here, but just to really emphasize that I could bring it out in front. And the reason I did that is now what's in the yellow box matches perfectly with the formula. So sometimes we get excited that, oh, there's a formula that's close. You want to do your substitution right away. Often you make mistakes if you substitute too quickly. We did have to take a little bit of time to rearrange things to make it match up perfectly. And now I can change this in the yellow box. The negative would still be out in front. Tan of 2 times pi over 6. This would be 2 over 1. That simplifies to negative tan of pi over 3, which is on your unit circle, and you get negative root 3. Put this back and you're allowed to use this on your next exam. Now I'm going to add, because I was complaining about the textbook, so I'm going to add 2 questions here that are better uses of this example. Because both A and B, you could have evaluated just using your unit circle and not have done any of that extra work, and it probably would have been easier. So for part C, I'm going to get you to evaluate without a calculator. One minus 2 sine squared of pi over 8. So if this is a non-calculator question, first thing you should notice is you've never seen a question with pi over 8 before. It is definitely not on your unit circle. So the only thing we're going to be able to do is if there's some sort of formula or manipulation that we can change this to. And check on your formula sheet. Does 1 minus 2 sine squared of something show up? Yes, it is one of the cos formulas. So I can change this to cos of 2 times pi over 8. And of course, the 2 is like 2 over 1. So if you multiply that out, that simplifies to cos of pi over 4. And all of a sudden it becomes doable because pi over 4 is on our unit circle. And it's just root 2 over 2. Now remember yesterday we did pi over 12 questions. Okay? The key things to remember from the pi over 12 questions is that you are going to use one of these formulas that have alpha plus beta, and you always use a pi over 4 plus something else to make it work. So if you have a pi over 12 question, you're going to use alpha plus betas, and you're always going to use a pi over 4. They're very predictable, so students who study them like them because you get to your pi over 12 question on your test and you're like, I know how to do this, easy 3 out of 3 or 4 out of 4 marks. Okay? 1 year on a final exam, they had this question. Evaluate 2 sine of pi over 12 times cos of pi over 12. Now, if one pi over 12 question is usually 3 or 4 marks, this one has 2 pi over 12s in it. And so you would think this question should probably be worth 6 or 7 marks, but on the final exam, it was only out of 2 marks. Now you guys have been in school long enough that you're used to like, oh, if this question is out of 4 marks, I need to show more work than if it's out of 1 mark, right? I was thinking, wouldn't it be kind of a psychological experiment to make a test where all the easy questions, they're like 4 marks, show all your work. And then the hard questions are like 1 mark. Would that throw you off? You probably wouldn't like that very much, right? You'd be like, what? I just did this in 1 step, Mr. JR, and it's 5 marks. What else am I supposed to show? It says, show all your work. That would drive you nuts. Think I don't do these things. think about them. I imagine what the students would do, but I don't actually do. So this one is truly only 2 marks, and the reason is because instead of doing it as a pi over 12 question, if you have your formulas memorized, you have a formula that has 2 sine alpha cos alpha. That's a sine 2 alpha formula, so that allows you to change this to the left-hand side, which is just sine 2 times pi over 12, and that was worth 1 mark. And if we multiply this as 2 over 1, and if we simplify this, this becomes sine of pi over 6, just on your unit circle is just a half, and there's the second mark. And all of a sudden, this is an easy, short question worth 2 marks. If you did it with the pi over 12, and some students tried, it took pages and pages of work, and then they had to multiply those root 6 plus root 2's over 4's together to try to figure out their final answer, and it was a little bit complicated. This is way easier. So the questions I'd like you to circle are 4, 5, and 6.